Hello friends, we are going to discuss here the unit number 6, that is a graph theory. So basically what is meant by graph? So graph which is collection of some vertices and some edges together, between them is nothing but the graph. So generally graph is represented by uppercase alphabet G, and which is represented as capital G is equals to ordered pair V comma E comma phi. Here G is the notation for graph, phi is nothing but the vertices, or it is also called as a nodes. E is nothing but the edges, and phi is the mapping between two vertices. So that is the formal definition of the graph. So talking about graph is classified into three types basically. The first one is the directed graph, second one is the undirected graph, and third one is the mixed graph. So in the case of directed graph, every edge is a directed, that's why it is called as the directed graph. In the case of undirected graph, there is no edge, there is no direction between that two nodes, or there is no directed edge. And in the case of mixed graph, some edges are directed and some edges are undirected. So that is the classification of directed, undirected, and mixed graph. So generally the directed graph are represented in the forms of ordered pair, and mixed graph and undirected graphs are represented in the form of regular, that is by representing the unordered pairs, because they are deals with domain to range and range to domain. Now talking about the very first important point as per the point of view to the examination, what is meant by in degree, out degree, and total degree. So basically in the case of in degree, out degree, and total degree is nothing but, so in degree is nothing but number of edges terminating at specific node is called as a in degree of that node. Out degree means what? Number of edges which is starting from that particular node is called as out degree, and total degree is nothing but in degree plus out degree is called as a total degree. And one more thing is that isolated node is having total degree is equals to 0. So what is meant by isolated node? The node which is not connected to the other node by any specific edge is called as an isolated node. Okay, so that is the formal definition of the in degree, out degree, and total degree. Okay, the next point is path of the graph. So what is meant by path of the graph? So for example, any sequence of edges in the given directed graph, keep in mind the graph should be directed, any sequence of the edges in the directed graph such that terminal node of the any edge is a initial node to the other edge. Terminal node of the any edge which is initial node to the other edge, if any appearing, then which is called as a path. Means what? For example, two edges are there. First edge having 1 to 2 and second one having 2 to 3. Then you can say here 1 to 2, 2 to 3 is called as a path. Okay, so path is a traverse through the nodes appearing in the sequence originating in the initial node of the first edge and ending in the terminal of the last edge of the sequence. Means for example, while finding the path, you have to start from the originating node of the first edge and last node of the terminating edge. Now length of the path. So you can see here how to find out the length of the path. So first of all, see the number of edges appearing in the sequence of path is called as a length of the path. The number of edges appearing in the sequence is called as a length of the path. So if you see, this is the directed graph given to you, and we have to find out the path from which is originating from 1 and ends at 3. So what to do? So number of possibilities are there. For example, 1 to, if I want to reach from 1 to 3, so what are the possibilities? I can go from 1 to 2, that is the first possibility. 1 to 2 is there. Okay, then I can go from 2 to 3, so that is the possibility. Fine. 1 to 2 and 2 to 3, 1 to 2 and 2 to 3, that is the first path which having the length 2, because this is the first edge and this is the second edge. Then next one, I can reach to 3 from 1 to 4 and 4 to 3, again it having the length 2. Then I can traverse from 1 to 1. Okay, I can traverse from 1 to 1, then I can go from 1 to 4, then 4 to 1, again I'll be written, then 1 to 2 is there, and 2 to 3. So here total length is 5. and one more is 1 to 2, 2 to 4, 4 to 3, which having the length 3. Number of possibilities are there. Just for the finding length, I have mentioned here how to find out the length of the path. Keep in mind this. Then next one, accessibility or reachability, accessible or reachable point. So you can say here a node V is reachable from U. You can see here, you can go in the direction U to V, means V is reachable from U, but U is not reachable from V. V is reachable from U, but U is not reachable from V. Likewise, this V is not reachable from U, and vice versa. This U is also not reachable from V, and V is not reachable from U. Okay. Then this U is reachable from W. This U is reachable from W, but W is not reachable from U. Then here V is reachable from W and W is not reachable from V. So that is the reachability and non-reachability of the nodes, or you can say reachability or accessibility of the given nodes. Then next one, what is meant by geodesic distance? So geodesic distance, which is nothing but the minimum distance to traverse from source node to the destination node, which is nothing but the geodesic node or geodesic distance. For example, geodesic distance of the specific node is equals to 0. For example, every node is reachable from itself. U is reachable from U, V is reachable from V, W is reachable from W, and geodesic distance of this W from W is equals to 0. Geodesic distance of U to V, because as we are reaching from U to V and it having the length is equals to 1, so geodesic distance of D of UV is equals to 1. Keep in mind. Fine. Then next point, reachability. You can see here the reachability of any node is denoted by R of V, where V is the node. So if you see here R of V1, so reachability of V1, so from V1 you can reach to V1 itself, V2, then you can reach to V3, V4, then you can reach to V5, V6 and V7. So reachability of V1 is these 7 nodes. Then talking about reachability of V2, V3, V4, V5 is same in the given diagram. Reachability of V6 is V6 itself and V7. You can see reachability of V8 is V8 itself. Reachability of V7 is V7 itself. Okay. Reachability of V9, V9. Reachability of V10 is V10. Here this V10 is the isolated node. Keep in mind, because it is not connected to the any other node from the given graph. So that's why this V10 and V9 also isolated nodes. Then next one, connectivity of the graph or connectedness of the graph. The graph is connected by 3 methods. The first one is the strongly connected graph, second one is the weakly connected graph, and third one is the unilaterally connected graph. So when the given graph is said to be strongly connected graph, for example, let's take this diagram. This diagram which consists of strongly connected graph because it containing 4 nodes 1, 2, 3, 4. So if you see, you can reach from this 1 to 2, 2 to this 3, 3 to 1. Okay. Then you can reach from this 1 to 4 directly. Then you can reach from this 4 to 1 via this direction, and likewise. Means every node is reachable from each other. That's why it is called as a strongly connected graph. You can see here every node. You can reach from this node to this node, this node, this node. You can check any case. So that's why it is called as a strongly connected graph. Now, what is meant by weakly connected graph? So the node U is reachable from V, but V is not reachable from U. Means what? You can reach from U to V. You can reach from one node to another node. Okay. But you cannot come back to that originating nodes. So in that case, it is called as a weakly connected graph. Okay. You can reach from U to V, but not reach from V to U. That is called as a weakly connected. And what is meant by unilaterally connected? Very interesting. At least one of the node reachable from another. At least one of the node reachable from another. So you can see here the diagrams. This one is the, as we earlier mentioned, this is the strongly connected. This one is the weakly connected, but not unilaterally connected. You can see here, you can reach from this position to this position, but you cannot come back to this position. In this case, you can reach from this point, but cannot come to this point. So if you check every point, then you can go from one node to the another node, but you cannot come back to the originating node. So that's why this diagram is called as a weakly connected. And what is meant by unilaterally connected? Uni means singly. So you can see here at least one of the node reachable from another. So you can see here. So if you see the difference between here, so if you consider this node, so you can reach from this node to this node. If you are reaching from this node to this node, also you can check here. Consider this one as a 1, this one as a 2. I am mentioning your numbers so that you will get the idea. 1, 2, 3, 4. Okay. So if you see, you can reach from 1 to 2, but 2 to 1 is not possible. You can reach from 3 to 2. 3 to 2 you can reach, but there is no possibility from 2 to 3. You can reach from 3 to 4. You can reach from 3 to 4, but there is no possibility from 4 to 3. You can reach from 4 to 1. That is interesting. You can reach from 4 to 1, and you can check here. Simply you can see 3 to 4 is there. 3 to 4 is there, and you can go in the upward direction so that it will be reached to the previous point. Okay, so that is the unilaterally connected. What is meant by simple graph? A graph contain nodes which not having more than one edge. The graph contain nodes which not having more than one edge is called as a simple graph. So that is the examples of simple graph. This one is simple, this one is simple, this one is simple also. This one strongly connected graph. Okay. The next one, multiplicity of the edge. So what is meant by multiplicity? If you see here, multiplicity, you can see here 1, 2, 3. 3 nodes are there. Between 1 and 2, there are 2 edges. Between 1 and 3, there is a 1 edge. Between 2 and 3, there are 2 edges. At 2, there are 2 self loops. So rather than mentioning all these edges and all these loops, you can see here between 1 and 2, as it containing 2 edges, directly we have written here 2. Here 2 loops are there, written here 2. 2 edges are there, written here 2. And 1 edge is there, so written here 1. So that is when this one is called as a multiplicity of the edge. This is nothing but the multiplicity of the edge. The graph will be represented as this one. The original graph was containing number of edges. Rather than representing number of edges, we have represented this by this number, that is called as a multiplicity of the edge. Then null graph. Null graph means what? The set of edges in the null graph is empty. So if you see here, here is one node V1, here is V2 as another node, and set of edges. So there is no edge between V1 and V2. So that's why it is called as a null graph. And also you can say this V1 and V2 are isolated to each other. Then next one, isomorphic graph. You can see here isomorphic graph. What is meant by isomorphic? Two graphs are isomorphic if there exists one-to-one corresponding between the nodes of the two graphs, which preserves adjacency of the nodes as well as the direction of the edges, if any. Means, for example, two graphs are said to be isomorphic when, for example, it should be having one-to-one corresponding. For example, G1 and G2, these are the two graphs. Then whatever number of edges present in G1, that much amount of edges should be present in G2. Talking about nodes, it should be having same number of nodes, as well as talking about the direction, it should having the same direction. Then the given two graphs are said to be isomorphic graph. So you can see here, this is the one example. Let us say this one is a G1, and next one is the, you can say this one is the another graph, that is a G2. So if you going through the G1 and G2, so that in the previous one, that is one is mapping with V3, one is mapping with U3, 2 is mapping with U1, 3 is mapping with U4, and 4 is mapping with U2. And you can mention here ordered pair 1, 2 is mapped with U3, U1, 1, 3 is mapped with U3, U4, 3, 4 is mapped with V4, V2, and 2, 4 is mapped with V1, V2. So that is nothing but the 1 to 1 mapping between ordered pair, 1 to 1 mapping between the nodes. Okay, so that's why the G1 and this G2 are called as isomorphic graph or isomorphic of each other. Fine. Now the next definition is cycle. As the name suggests that cycle, the path which originates and ends at the same node is called as a cycle, or it is also called as a circuit. Means, for example, if the source node is 1, the destination node must be 1. So if you see here, C1 is the first possible cycle which having source node as a 1, destination node as a 1. So that's why it is called as an elementary cycle, because 1 is there and a single edge is there. So that's why it is called as a elementary cycle. Then next one, 1 to 2 1, it having path length as a 2. Again it is a cycle. This one having path length 3, and path length as a 4. So the C2, C3, C4 and C5, these are the cycles, and C1 is the elementary cycle. Fine, because as elementary name suggests, it having the only one edge, that is a 1 1. Now very important point, matrix representation of the graph. So how to represent the matrix of the given graph? So basically diagrammatical representation of graph have limited usefulness. So it has to be represented in the matrix form. Possible only at the number of nodes and edges are reasonably small. Useful in path cycle and their characteristics of the graph. Now see, if G of V is the simple diagram with V is equals to V1, V2 up to Vn nodes having order from V1 to Vn, then n by n is a matrix given as follow. Means for example, if G of V is the given graph where V is the vertices, let us say n vertices are given to you, then matrix should be n by n. And how to plot the elements in the given matrix? So for that purpose we are using here adjacency matrix. So A of ij, so A of ij is nothing but adjacency matrix element. When we are going to plot this as a 1, whenever V of I, V of j is present, that is belongs to E, then we have to mention here 1, otherwise we have to mention this as a 0. That is the adjacency matrix. The adjacency matrix is either 0 or 1. It is called as a bit matrix or Boolean matrix. It is also called as a bit matrix, or it is called as a Boolean matrix, because generally bit or Booleans are also counted in 0 and 1. Okay. From the graph we have drawn matrix as follows. Now see, this one is the one graph is given to you, that is a directed graph is given to you, which containing V1, V2, V3 and V4 as a 4 nodes. Then adjacency matrix. So V1 will be V1 map with V1 0. Yes, V1 to V2 is reachability, so that's why 1 is there. Whether V1 to V3 is there? No, 0. Then V1 to V4 is there? No, 0. Then talking about 2 to 1, that is V2 to V1, no. V2 to V2, no. V2 to V3 is there? Yes, that's why 1. Then V2 to V4 is yes, that's why 1. So likewise we have find out the adjacency matrix, that is a A1. We have find out the adjacency matrix A1, and that A1 is equals to, as I mentioned here, A1 is equals to 0 1 0 0 0 0 1 1 1 1 0 1 1 0 0 0. When the given matrices is called as a reflexive property. When the given matrix is having the reflexive property, when all the diagonal elements are identical and 1, then it should be 1, not 0, it should be 1, then it is called as a reflexive property. Symmetric is what? When A of ij is equals to A of j, then it is called as a symmetry. Okay, so original matrix and the transpose of the matrix should be identical. Original matrix and the transpose of the matrix are identical, then it is called as a symmetric property. Then antisymmetric. If A of ij is equals to 1, then A of ji is equals to 0. If A of ji is equals to 1, then A of ij is equals to 0. So that is nothing but the antisymmetric property. Now, what is meant by transpose? So in the case of transpose, we are going to find out, if you see here 0 1 0, this is the first row, that is a 0 1 0 0, and which is becomes here 0 1 0 0. Okay, so that is nothing but the transpose. We are going to transfer rows to column and columns to rows. So that is why it is represented as a raised to t. So a into a raised to t is equals to this one. You can make the rows and column wise multiplication, and 18 into a is equals to 2101. So this one and this one having different meaning, because here a into at and here is 18 into a. So we can simply take it as b is equals to this one. Now, what is meant by a square, a cube, a raised to 4 and a raised to n, where n is equals to 2 3 4. And what is the value of n? So as we know that number of nodes, you can see here number of nodes are 4, so we have to find out this value up to a4. Okay, so if number of nodes are 5, then it will be up to 5. Number of nodes are 3, then it is up to 3, and likewise. So if there are two paths from v2 to v1 of length 1, that is a square. Means what it will be represented? If there are two paths from v2 to v1 of length 1, then it is represented by a square. and also 4 paths from V2 to V1, then it is represented by a raised to 4. Fine. And by using this, we can find out the path matrix, or we can find out here path, which is equals to a1 a square a raised to 3 a raised to r. This r is nothing but number of vertices. Previously we have seen 4 vertices were there. So this equation will be a1, a2, a3 and up to a4. Not need to exceed again. Okay. So you can see here Bn is equals to a1, a2, a3, a4. Fine. Now, so from this given diagram, we have find out here a1, that is 0, 1, 0, 0. You have to find out this. Then a square is what? You have to take here this matrix, again take this matrix and make the multiplication. A cube is equals to a into a square, that is this one. Okay. And again, one more thing is missing over here. It's my mistake. You have to find out here a4 also. Why you have to find out here a4? Because here 1, 2, 3, 4. 4 nodes are there. We should not be restrict up to a raised to cube. You have to find out here a raised to 4. And by finding a raised to 4, you can take here b4. This will be b4. b4 will be equals to b1. b4 will be equals to a1, a2, a3 and a4. Make this correction. You have to find out a raised to 4 as a into a cube. By using this value of a cube, you have to find out a raised to 4. That a raised to 4 which is equals to a into a cube. And then you have to take the summation. That is, you have to take here a1 plus a square plus a cube plus a4, and finally you have to find out the path matrix, that is b raised to 4. And whenever all the elements are non-zero, it means that there is a path between every element with each other. So that's why you can mention this as a p is equals to 1, 1, 1, 1 and so on. Means it having path over there. So that is the path and reachability matrix. Now the next point, very important point as per the point of examination, PERT and CPM. So what is meant by PERT? It is program evaluation and review technique, or it is also called as a project evaluation and review technique. And under this we are using critical path method. And the critical path method, what is the use of this? One by one we are discussing here. So what is meant by PERT? It is the project management tool designed to analyze, planning, scheduling and coordinate complex problems. So to solve or to analyze or to schedule or to plan, we are coordinating complex problem by using the PERT. So what is the necessity for the PERT? The first one is what? It should be directed graph. There should be directed graph, no parallel edges, then no multiplicity of the edge, means there should not be more than one edge between two adjacent nodes, one source node with in degree 0, which is also called as a source node. Okay, one sink node or destination node with out degree 0, no elementary cycle, there should not be cycle between specific on specific node. And two methods are there. First method is called as a traveling early method, and second method is called as a traveling latest method. So in the traveling early method, we are traversing from source nodes and reach to the destination node or sink node. And in the traveling latest, we are traverse from destination node or sink node and we are traverse towards the source node. And last point is slack value. So what is meant by slack value? It is the difference between traveling early and traveling latest value, that is TE minus TL. Fine. Now what is meant by critical path? So how to find out the critical path? So critical path, it is the path from source node to the destination node connecting all other nodes which having slack value as 0. Definitely, as we are finding path between source node to the destination node, means definitely source node should be there and destination node should be there. But rather than source node and destination node, those nodes having slack value as a 0, we have to take that node in the critical path. It gives distance from source node to the destination node. Now let us take one example, you will be get the idea. So see the example what it says. So V1 is the source node and V6 is the destination nodes or sink node, and it having total 6 nodes, that is V1, V2, V3, V4, V5 and V6. So keep in mind, whenever you are traversing from source node to the destination node, you have to go in ascending order. Means what? Whenever you are finding here V1, you should be go for a V2 unless and until there is a direction between V1 to V3. You can't directly go to the V3. Okay, so you have to go from V1, then you have to go to the V2, then you have to go to the, you have to find out the V3, then find out V4, find out V5, and then go for the V6. Otherwise, if you go directly from V1 to V3 or V1 to V4 directly without finding V2 and V3 previously, the resultant will be wrong. Fine. So now let us see the traveling early method. So what is the traveling early method? It is a method which is traversed from source node to the destination node. It is the method which is traversed from source node to the destination node. So what is the step 1 says? Step 1 says traveling early of source node is always 0. So that is the thing you have to keep in mind. So that is traveling early of V1 is equals to 0. So it having the traveling early as a 0. Now you have to go for V2. So you can see here, we have to find out the traveling early of other nodes in the ascending order, that is V1, V2, V3, V4, V5 and V6 accordingly. So as I mentioned earlier, once you find out the traveling early value of V1, you have to go for traveling early value of V2. So how to find out the traveling early value of V2? So let us see here. So step number 2, traveling early of V2. So maximum of V1, V2. So what is the possibility to reach V2? There is a single possibility from V1 to V2, that is age V1, V2. So directly you can write here maximum of V1, V2 and maximum of V1, V2. So what is the V1, V2? That is 1. So you can write here maximum of 1. A single value is there. So directly you can write here traveling early of V2 is equals to 1. So once you find out the traveling early of V2, you have to go for traveling early of V3. So in the case of V3, you can see here, to the V3, you can see to the V3, you can reach via V2 or you can directly came from V1. Okay, so there are two possibilities you can see here. Yes. So maximum of traveling early of V2, because already we have find out here traveling early of V2 plus age V2 V3 plus, that is V2 plus V2 V3, and another possibility is what? V1 to V3 directly, V1 to V3 directly, V1 to V3 directly. So what is the value here? So traveling early of V2 is 1, then V2 to V3 is 1, comma 3. So what is the maximum? 3. So traveling early value of V3 is equals to 3. Then step number 4, you have to find out traveling early of V4. So if you see the diagram properly of that PERT, you can see we have find out V3 before the V4, V2 before the V3 and V1 at the very beginning stage. So for the V4, there are two possibilities. We can reach from V1 to V4 directly and V3 to V4 directly. So while reaching from V3 to V4, we have to take here traveling early value of V3 plus V3 V4 and traveling early of V1 plus V1 V4. So maximum of 3 plus 1 already we have find out, 0 plus 5. So maximum is 4 comma 5, maximum is 5. Yes. Then in the step number 5 you have to find out here traveling early of V5, which is nothing but maximum. Keep in mind guys, you have to go with this diagram. As I solve this example, I am directly going by looking towards the example, but you have to draw this example and go step by step what I am saying here. So traveling early value of V5, which is equals to maximum of traveling early of V2, because V2 is directly connected to the V5, so that's why traveling early of V2. Then V2 V5 age is there. Okay, keep in mind we have to take addition over here. By mistake I have mentioned here minus. Here should be addition. Then traveling early of V4 plus V4 V5. So you can write here maximum of 1 plus 2. Yes, maximum of 1 plus 2 comma 5 plus 1. So maximum of 3 6, which is equals to 6. So traveling early of V6 is equals to 6. Fine. So keep in mind once again this is a plus sign. Okay. And finally step number 6, that is a traveling early value of V6. Traveling early value of V6 is equals to maximum of, for the V6 we can reach from V3 to V6, we can reach from V4 to V6, we can reach from V5 to V6. You can see here V3 to V6 we can reach, V4 to V6 we can reach, and V5 to V6 we can reach. So that's why you can take here V4, V5 and V3, V4, V5 and V3, and adjacent edges are there. And out of this you can find here 6 plus 2, 5 plus 2, 3 plus 2, which is equals to maximum of them, that is 8. So traveling early value of V6, which is equals to 8. So as we reach to the sync node, or as we reach to the destination node, we have to stop our traversing. So that's all for the traveling early method. Now we have to coming back from source node, sync node to the source node. So it is the traversing from destination or sync node to the source node, that is called as a traveling latest. So what is the step number 1? Initially traveling latest of sync node, which is same as traveling early of the latest node. Means whatever the values we have find out in the traveling early with respect to the source node, we have to take as it is. So that's why traveling latest of V6, which is equals to traveling early of V6, which is nothing but the 8. Means whatever the values we have find out in the traveling early method. Now we have to go in the descending order from V6 to V1. Means first of all you have to find out V6 as we mentioned here. Then you have to go for V4, V5, V4, V3, V2 and V1. That is in descending order. Now, so what will be the step number 2? You have to find out V2. So you have to find out here V5. So while going from going in the traveling latest method, you have to find out the minimum value, and you have to traverse from sync node to the source node. So which is equals to minimum of traveling latest of V6 minus the adjacent is V5 comma V6, which is nothing but minimum of 8 minus 2, which is equals to 6. Fine. Then once you find out traveling latest of V5, you have to go for traveling latest of V4, which is equals to, so with respect to V4 we having traveling latest of V4 and traveling latest of V6 and traveling latest of V5 minus adjacent edges. So minimum of this one is 5. So likewise you can go for V3. V3 will gives you here 4. Then you can go for V2, which gives you 3. Please go through this. You have to solve this. Otherwise it is not possible to solve in the university examination. And finally for the V1, traveling latest value, which is equals to 0. So that is the method. Once you reach to the source node, you have to stop the traversing. Now we have constructed the table. So node is what? V1, V2, V3, V4, V5, V6. Fine. So these are the nodes. So these are the traveling early values and these are the traveling latest values. Okay. So whatever the values we have calculated, we have mentioned over here. So traveling early value of V1 is 0. Traveling latest value of V1 is 0. So difference is 0. So you have to take by default in the critical path. Then 1, 3 is there. Difference of 2. You cannot take this. 3, 4 is there. Difference of 4. You cannot take there. 5, 5. Yes, you can take. Then 6, 6 you can take. Then 8, 8 you can take. So you are going to take V1, then V4, V5 and V6 in your critical path. So hence your critical path is V1 to V4, V1 to V4, V4 to V5, V5 to V6. So that is the critical path. V1 to V4, V4 to this V6. You have to mention this in the examination as it is given in the given PERT. So that is the critical path. V1 to V4, V4 to V5, V5 to V6, and it having the length equals to 8. Okay, so that's all for the CPM and PERT. Very important. It will be asked for the university examination. Fine. And one more example I would like to explain over here. Isomorphic graph. Two graphs are said to be isomorphic if and only if there is one-to-one corresponding between, see, one-to-one corresponding between vertices, edges, degree sequence and cycle. So these are the 4 conditions. So these 2 graphs are given to you. G1, which containing 8 nodes, that is A, B, C, D on the left side, G, H, I, J on the right side, and they are connected among them. And on the right side, G2 is equals to 1, 2, 3, 4 outside, and inside 5, 6, 7, 8. So you have to show that this G1 and G2 are isomorphic with each other. So for that purpose, vertices. So if you see G1 and G2 both having equal number of vertices. So with respect to vertices, it may be the isomorphic. We are not confident by only vertices, directly we can say the isomorphic. But number of vertices in G1 equals to number of vertices is G2. So that's why you can say that it may be isomorphic with respect to the vertices. Then edges. So if you see the edges, total number of edges in the G1, total number of edges in G1 is equals to 12, and total number of edges in G2 is equals to again 12. So they are mapping likewise, that AG, which is map as 1 to 5, AH, which is map as 1 to 2, and likewise all these are mapped with each other. Okay, then vertices mapping G of A. So G of A, which is mapped with 1, G of A is mapped with 1, G of B, which is mapped with 6, then G of C, which is mapped with 8, and likewise all these. G of C is mapped with 8, G of D is mapped with 3, G of G is mapped with 5, G of H is mapped with 2, G of I is equals to 4, G of J is equals to 7. And the next one and the last one, cycle mapping. What we are going to do in cycle mapping, there is a number of cycles present, but we can check some of them. Not possible to find out all the cycles, but you can see here G2 is equals to 1, 2, 3, 4 is cycle, 5, 6, 7 is also cycle, which are same as in G1 as AGBH and ICJD. So whatever the meaning of 1, 2, 3, 4, you can see here 1, 2, 3, 4, that is a AH. Make little bit correction. Here should be 1, 2, 3, 4. 1, 2, 3, 4 means what? A H A H D I. Please make correction over here. Okay, so you have to make the correction. I am writing here. Sorry for mistake. It should be A, then H, H D I. Now it is correct. Fine. So instead of this, you have to take this one. And in this case, you can take here G. You can take here G, then C, then J is nothing but just wait. Just wait for a moment. 5 is nothing but G, then C is nothing but 5 is nothing but, then 6 is nothing but B. Sorry for mistake. Here is B, then GB, then 7 is nothing but J, and finally 8 is nothing but, yes, 8 is nothing but C. So that is the mapping. Please correct this one as correct. These two are not correct by mistake. Okay, this one is not correct. These both are wrong. This one is correct and this one is correct. Yes. Similarly, we can map also number of nodes, number of degree of the nodes. For example, nodes in G1, that is A, B, C, D, G, H, I, J, A, B, C, D, G, H, I, J, and nodes in G2, that is 1, 6, 8, 3, 5, 2, 4, 7. Both having number of degrees equals 3, 3, and likewise 3, 3. So degree wise is also same. So hence it having, you can see, same number of vertices are there. Yes, same number of edges are there. Degree sequence is same. Cycle is same. So that's why this one, the LHS and RHS, both are called as isomorphic of each other. Fine. They are called as isomorphic of each other. So that's all for the chapter number 6, that is graph theory. What we have discussed here, what is meant by path, what is meant by null graph, what is meant by cycle of graph, what is meant by simple graph, multi-graph, reachable node, total degree of node, isomorphic graph, and so on. We have seen what is meant by strongly connected graph, weakly connected graph, unilaterally connected graph. Then we have seen one example of isomorphic graph. Then we have seen what is meant by matrix representation, how the path matrix can be found out. That is B of n is equals to A1 plus A2 plus A3 plus A raised to n. So that is the path matrix. Then what is meant by reachability matrix, what is meant by adjacency matrix. Then we have seen what is meant by PERT, that is a program evaluation and review technique, and what is meant by CPM, that is a critical path method. So that's all for the chapter number 6. Tomorrow we will be discuss the chapter number 4 and 5, which is remaining. But keep in mind that, guys and girls, whatever I have discussing in the all these four recorded videos, it is very, very important. It has to be do by you people. It is helpful to you. Thank you so much for your patient listening.